Let's say you're an architect and your client, for some reason, would like to build a huge statue of a football in the middle of a park. How can you do it? First, let's start by drawing a Cartesian plane in the place where you want the structure to be placed. Then, let's assume that you want it in the middle of a park. And since the football is horizontal, the major axis of the so-called ellipse will be placed on the x-axis. Now let's ask our client how long and how wide would he want the statue. 60 meters wide and 40 feet tall. In our Cartesian plane, since the measures are too large, let's count to 10 instead. With these measures, now we can find out the value of A, B, and C. 60 meters will be the measure of our major axis, while 40 feet will be the measure of our minor axis. Now, the formula of major axis is 2A. And since 60 meters is the measure of our major axis, we will take 60 and divide it into 2. That will be 30. The value of our A will be 30. Now let's find out the value of our B. Since the formula of our minor axis is 2 times B, let's use it the other way around and divide 40 by 2. 40 divided by 2 is equals to 20. Therefore, the value of our B will be 20. But before we can find out the value of our C, let us first try to solve the value of our A squared, B squared, and C squared. So we will just square the value of our A. 30 squared will be 900. Same goes to B squared. 20 times 20 or 20 squared is equals to 400. Then to get our C squared, we can just take the value of our A squared and subtract it to our B squared. So 900 minus 400 is equals to 500. So the value of our C squared is 500. Let us find the square root of 500 to find the value of our letter C. 500 has no perfect square, so our answer will be in decimal form. The square root of 500 is 22.36. Now we have completed the value of our A, B, and C in our A squared, B squared, and C squared. Let us now find the measure of the parts of the ellipse. The formula states that our vertices should come from the value of our A, and the value of our A is 30. Then the major axis is located in x-axis. Therefore, 30 will be located in x. So the value of our vertices will be 30 and 0, and negative 30 and 0. Same goes for the foci. Our foci should come from the value of our C, and the value of our C is 22.36. So our foci should be 22.36 and 0, and negative 22.36 and 0. But co-vertices are different. Co-vertices are the complete opposite of vertices. So instead of placing the value in the x, it should be placed on the y. So the coordinate of co-vertices would be 0 and 20, since our value should come from the value of letter B. So it will be 0 and 20, 0 and negative 20. Now for my least favorite part, the endpoints. Let's take a look at our foci and take the value that is not 0, 22.36. Now for the y coordinates, let's use the formula of b squared over a. The value of our b squared is 400 and the value of our a is 30. So 400 divided by 30 is 13.33. Our endpoints should have 4 coordinates. So it will be 22.36 and 13.33. negative 22.36 and negative 13.33, negative 22.36 and positive 13.33, positive 22.36 and negative 13.33. For our directrices, let's use the formula of a squared over c. The value of a squared is 900. So 900 divided by 22.36 is 40.25. And since our major axis is located in x-axis, our directrices will be placed in x-axis. So the value of our directrices will be x equals positive negative 40.25. Now for our eccentricity, we will use the formula of c over a. 22.36 divided by 30 is 0.75. Now for the length of lateral recta is 2b squared over a. 400 times 2 and divided by 30 is equal to 26.67. Now, we have completed computing for the parts of the ellipse. Let us now graph using our Cartesian plane. And that is how you solve an ellipse. I hope I made things more easier for you in case your client wants to build you a huge statue of a football. Thank you and goodbye!